There's a creature at the bottom of the ocean that simply should not exist. Not because it is rare or hidden, but because what it can do violates the laws of physics and biology. It fits in the palm of your hand and looks like a colorful little toy, but it can throw a punch that moves faster than a bullet. For decades we have studied it, filming it at over 100,000 frames per second and trying to replicate its anatomy in labs. We still can't fully explain how it works. This is the mantis shrimp, and this is why scientists are both fascinated and a little afraid of it. Let's start with the obvious. The punch. The mantis shrimp club specializes appendage uses to strike accelerates at 10,000 times the force of gravity. That is faster than a .22 caliber bullet having a gun barrel. But here's what most people don't know. The speed itself is not even the most dangerous part. When that club moves through the water that fast, it creates something called a cavitation bubble, a pocket of near vacuum that forms and then violently collapses in microseconds. The collapse releases a flash of heat, briefly reaching temperatures close to the surface of the sun, and a shockwave powerful enough to stun, wound, or kill prey entirely on its own. So the mantis shrimp does not punch its prey once. It hits it twice. The club, then the shockwave. A mantis shrimp kept in a standard aquarium tank once shattered the glass with a single strike. Not cracked, shattered. Marine biologists now house them in specially enforced enclosures, a 2-inch crustacean that requires containment, designed for dangerous animals. But the punch, extraordinary as it is not even the most scientifically baffling about this creature. Engineers at UC Riverside spent years studying the club itself, not to understand the animal, but to steal from it, because the mantis shrimp club absorbs and redistributes impact forces in a way that no human-made material can replicate. The outer surface is made of hydroxyapatite, the same mineral in your bones, but beneath that, the fibers are arranged in a helix, a rotating spiral that directs crack propagation, forcing fractures to spiral outward rather than splitting through. What that means, in plain language, the club should crack every time it strikes. The forces involved should shatter it, but it doesn't, because the internal structure roots the damage away from itself. The researchers tried to build a helmet material based on this design. Carbon fiber, arranged in the same helix pattern. It outperformed every existing composite material in impact resistance. The mantis shrimp invented that somewhere between 400 to 500 million years ago. Now we need to talk about the eyes. You have 3 types of photoreceptors. 3. They detect red, green, and blue light, and your brain blends them into the full spectrum color you see right now. The mantis shrimp has 16 photoreceptor types, including receptors turned to violet and infrared light wavelengths completely invisible to every other vertebrate on Earth. For years, scientists assumed this meant the mantis shrimp experienced color in a way too complex for us to imagine, a visual world of impossible richness. Then they ran the behavioral tests, and the results were strange. The mantis shrimp is actually worse at distinguishing between similar colors than humans are. It does not blend colors the way we do. Instead, each photoreceptor functions more like a binary switch. It either fires or it doesn't. The shrimp identifies colors by which receptors activate, not by comparing activation levels across receptors. It is not seeing richer color, it's seeing color faster, processing visual information in a way that completely bypasses the need for brain to do comparative analysis. It is not a richer experience of color, it's a different operating system entirely. Scientists don't fully understand why it evolved this way, or what it actually perceiving. Most animals at this level of the food chain operate on instinct, stimulus, and response, no more complex than firing of neurons following ancient chemical pathways. The mantis shrimp does not appear to work this way. They are aggressively territorial. They maintain burrows they actively defend and modify. They have all been documented, returning to the same burrow sites for years. And in laboratory settings, they have demonstrated something that has made researchers deeply uncomfortable. They recognize individual humans, not by smell, not by size, but by face. Researchers who handled mantis shrimp regularly were struck more frequently and more forcefully than unfamiliar researchers. The shrimp remembered them, and it had opinions about them. An animal with a brain roughly size of a grain of rice, holding grudges. The mantis shrimp has been on this planet for over 400 million years. It survived 5 mass extinction events. It watched the dinosaurs rise and fall from bottom of the shallow sea. And in that time, it developed a punch that rivals firearms, a skeleton that outperforms aerospace materials, a visual system that operates on entirely different principles to every other animal with eyes, and a memory that holds a grudge. We have studied it for decades, and we still cannot fully explain it, which raises a question scientists don't like to say out loud. What else is down there that we haven't looked at yet? Stay tuned for more stranger species topics. See you in the next video.